Hello viewers, welcome to Sleepy Mind Channel. Tonight we'll be exploring weird planets. Imagine you are a lost astronaut pulling up to a foreign solar system. Your fuel is running low, your oxygen alarms are blaring, and your eyes are burning from looking at static black space for months. Suddenly, through the cockpit window, you see it. A beautiful, serene, deep cobalt blue planet. It looks exactly like Earth from a distance. You sigh with relief, thinking you've found a sanctuary, a place to rest, a place with oceans and rain. You steer your ship into the atmosphere, preparing for landing. But as you break through the upper clouds, the blue doesn't turn into water. The temperature gauge on your dashboard explodes. The wind catches your ship, spinning it like a leaf in a hurricane. And suddenly, a sound hits your hull, a metallic, screeching roar that sounds like a billion mirrors being crushed at once. Before you can even process the horror, the air itself rips your spaceship's titanium hull to shreds. The rain hitting your windshield isn't water. It is liquid glass, moving sideways at 7 times the speed of sound, cutting through metal, bone, and flesh in a fraction of a millisecond. Welcome to HD 189733b, the cosmic optical illusion that uses the color of life to mask a house of pure death. Located just 64 light-years away in the constellation of Vulpecula, HD 189733b is a planet that scientists call a hot Jupiter. It is a massive gas giant, slightly larger than the largest planet in our solar system, but it lives in a state of perpetual torment. While our Jupiter sits comfortably in the cold outer edges of the solar system, taking 12 years to orbit the Sun, HD 189733b is practically hugging its parent star. It is so incredibly close that it completes a full orbit, a literal planetary year, in just 2.2 Earth days. Because of this dangerous proximity, the planet has become tidally locked. This means the gravitational pull of the star is so violent that it has locked the planet's rotation in place. One side of the planet permanently faces the roaring, nuclear furnace of its sun, condemned to an eternal, blinding day where temperatures skyrocket to a devastating 1,700 degrees Fahrenheit. The other side of the planet is turned away, facing the empty void of space in a state of permanent, freezing night. Now, think about basic meteorology. What happens when you have a planet where one half is a roaring furnace and the other half is freezing cold? The atmosphere panics. The extreme temperature difference creates a cosmic pressure cooker. Air from the day side desperately tries to rush over to the night side to cool down, unleashing apocalyptic winds that howl across the planet at over 5,400 miles per hour. To put that in perspective, that is Mach 7. It is 7 times the speed of sound. The fastest tornado ever recorded on Earth had winds of about 300 miles per hour. On HD 189733b, the wind moves 18 times faster than our deadliest natural disaster. But the wind isn't even the scariest part. The true horror lies in the planet's beautiful blue color. When astronomers first looked at this world through the Hubble Space Telescope, they were stunned by its gorgeous sapphire hue. But when they analyzed the light spectrum, they discovered a terrifying truth. The blue isn't caused by water oceans reflecting sunlight. It is caused by a thick, suffocating atmosphere packed with silicate particles, the raw material used to make glass. As the blazing star roasts the day side of the planet, it vaporizes these silicates, turning rock and sand into a gaseous state that rises into the atmosphere. But as the ferocious 5,400 miles per hour winds drag this vaporized rock toward the cooler night side, the temperature drops just enough for the silicates to condense. They turn back into liquid and then into tiny, razor-sharp particles of solid glass. Because the winds are moving at supersonic speeds, this glass doesn't fall down in peaceful vertical droplets. It rains entirely sideways. It is a global, never-ending, supersonic storm of flying shards. If you could stand on the surface, you wouldn't just be crushed by the atmospheric pressure. You would be violently sandblasted out of existence by a billion tiny flying mirrors. Why does HD 189733b disturb us so deeply? It's because of how human psychology is wired. As a species, we are inherently drawn to the color blue. When we see a blue sky, our brain releases cortisol-reducing hormones. We feel safe, relaxed, and grounded. Blue means a clear day. Blue means a deep, life-giving ocean. It is the color of our home, the pale blue. The only place in the vast, freezing universe where we know for a fact that we are safe. We find comfort on a rainy afternoon, sitting indoors, listening to the gentle pitter-patter of water drops hitting our window panes. To us, rain is a cleansing ritual of nature. It brings life to crops, cools down hot summer days, and inspires poetry. But HD 189733b takes that deeply embedded psychological safety and weaponizes it against us. It plays a cruel cosmic trick on our senses. It shows us that in the wider universe, nature does not care about our comfort zones. It reminds us that the features we consider beautiful, soothing, and divine on Earth are entirely accidental privileges. If our planet's chemistry had been just slightly different, our skies could have been a meat grinder of flying glass. It forces us to look at a simple rain shower on a Tuesday afternoon not as a mundane weather event, but as an extraordinary, fragile miracle. We are incredibly lucky that our skies choose to pour soft, life-giving water rather than tearing us apart with supersonic shards of glass. Look at the ring on your finger, or think about the most heavily guarded vaults in the world's biggest banks. Inside them sit diamonds, tiny, sparkling rocks that humans have killed for, started wars over, and spent lifetimes trying to afford. We value them because we are told they are the rarest, most precious things on Earth. We use them to symbolize eternal love, and we buy them to prove our status to society. Now, close your eyes and imagine a world where diamonds aren't small stones hidden deep underground. Imagine a planet twice the size of Earth, floating in the dark, where diamonds are as common as gravel, mud, and dirt. A world where entire mountains, valleys, and structural tectonic plates are made of pure, glittering, pressurized crystal carbon. A planet so immensely valuable that if you could somehow bring it back to Earth, it would be worth $26.9 nonillion, a number so large that it would instantly render all human currency completely worthless. Welcome to 55 Cancri E, the ultimate cosmic joke on human greed. Discovered in 2004 orbiting a sun-like star in the constellation of Cancer, 55 Cancri E is a heavyweight world. It is a super-Earth, meaning it is a rocky planet like ours, but it has a mass 8 times greater than Earth and is roughly twice as wide. But its size isn't what makes it a sci-fi dream. It's its internal chemistry. Our Earth is a silicate-based planet. Our crust and mantle are made mostly of oxygen, silicon, and iron, with only a tiny fraction of a percent of carbon mixed in. Because carbon is so scarce in our geology, diamonds, which are just carbon atoms squeezed into a tight crystalline structure, are incredibly rare to find near the surface. They require millions of years of intense heat and pressure deep within the Earth's mantle before volcanic eruptions push them up to a place where humans can mine them. But 55 Cancri E formed in a completely different kind of stellar nursery. Its environment was overflowing with carbon. When the planet solidified, it didn't become a ball of iron and silica. It became a massive ball of carbon and graphite. To make things even more extreme, 55 Cancri E orbits its star at a terrifyingly close distance. It sits 65 times closer to its sun than Earth does to our sun. Because it is so close, the gravitational grip of the star has locked it into a tight, frantic dance. The planet completes a full orbit in just 18 hours. Imagine that an entire year passes by before you can even finish a single day's work on Earth. This extreme proximity means the planet is subjected to a relentless onslaught of heat and pressure. The surface temperature on the day side reaches a hellish 4,000 degrees Fahrenheit. This isn't just hot enough to melt a human. It is hot enough to liquefy entire mountain ranges of rock. Scientists modeling the interior of this super-Earth discovered something breathtaking. While the surface of the day side is a churning, glowing ocean of liquid lava, the immense weight of the planet's outer layers creates an unimaginable gravitational pressure as you go deeper into the core. Under this combined assault of 4,000-degree heat and crushing planetary gravity, the massive amounts of carbon inside the planet cannot remain as soft graphite. The carbon atoms are violently forced together, locking into place and crystallizing. Astronomers estimate that at least 1/3 of the entire mass of 55 Cancri E is pure diamond. We aren't talking about a few carats found in a cave. We are talking about an entire layer of the planet, thousands of miles thick, consisting of solid, gleaming, unyielding diamond. If you could slice this planet in half, it would look like a colossal, cosmic disco ball cutting through the darkness of space, reflecting the fiery light of its nearby star in a blinding display of cosmic luxury. For centuries, human beings have built entire societies around the illusion of scarcity. We have decided that a diamond is worth a fortune simply because there aren't many of them accessible to us. The diamond industry has spent billions of dollars on marketing campaigns to convince us that these stones are the ultimate expression of human emotion, that the size of a diamond dictates the depth of your love. Men have spent years paying off debts just to buy an engagement ring, and nations have bled in blood diamond, war zones just to control the trade of these glittering rocks. But 55 Cancri E stands out there in the dark as a silent, mocking monument to our vanity. It proves that what we consider a priceless luxury on Earth is nothing more than a common celestial byproduct when the universe decides to turn up the heat and pressure. It shows us how incredibly narrow our definition of wealth is. If a spaceship could somehow drop a single mountain from 55 Cancri E into the middle of New York City, the global diamond market would instantly collapse to zero. Diamonds would become as cheap as asphalt. The status symbols people flaunt on red carpets would suddenly mean nothing. This glittering world forces us to look inward and reevaluate what is truly valuable. In a universe where an entire planet can be made of diamond, a sparkling rock isn't rare at all. You know what is actually rare? A breath of clean oxygen. A drop of liquid water that doesn't evaporate into gas. A patch of soil where a green seed can sprout into a flower. 55 Cancri E tells us that true wealth isn't found in the cold, hard crystals of an alien planet. It's found in the living, breathing, fragile ecosystem of our own home. A world that is far scarcer and more precious than a billion tons of diamond floating in the void. Look up at the night sky and think about Saturn. Even through a basic, low-cost backyard telescope, Saturn is an absolute showstopper. Its icy, elegant rings make it look like the undisputed artist of our solar system. A delicate, celestial jewel spinning peacefully in the dark. For generations, humans have stared at Saturn in absolute awe, romanticizing its beauty. But now, imagine a monster waking up in the deep dark of space that makes Saturn look like a microscopic joke. Imagine a planet so colossally massive, with a ring system so staggeringly gigantic, that it doesn't just wear a crown, it dominates the entire fabric of its solar system. If you were to rip Saturn out of its orbit and replace it with this cosmic titan, its rings wouldn't just be a tiny speck in our telescope. They would stretch across our night sky, appearing many times larger, wider, and brighter than the full moon. It would be so massive that it would blot out the stars, casting eerie, giant shadows across the continents of Earth, turning our night into a surreal, sci-fi twilight zone. Welcome to J1407b, the ultimate super Saturn that completely redefines the scale of cosmic grandeur. Discovered in 2012 by astronomers at the University of Rochester and the Leiden Observatory, J1407b is a world that genuinely shocked the scientific community. Located roughly 434 light-years away from us in the constellation of Centaurus, this world is a monstrous gas giant, or possibly a brown dwarf star, that possesses a mass anywhere from 10 to 40 times that of our Jupiter. But its physical mass isn't what left astronomers breathless. It was the shadow it cast on its parent star during an eclipse. When J1407b passed in front of its star, the eclipse didn't last for a few hours like a normal planet. The star's light flickered, dimmed, and danced erratically for an astonishing 56 days. When scientists analyzed the data to understand what could possibly block out a star's light for nearly 2 months, they realized they weren't looking at a normal planet. They were looking at a planetary system surrounded by an ultramassive structure of cosmic rings. Let's talk about the numbers because they are absolutely mind-boggling. Saturn's main ring system stretches out to about 175,000 miles. That sounds huge to a human, but the ring system of J1407b spans a staggering 74 million miles in diameter. That is nearly 200 times larger than Saturn's rings. To give you a physical sense of that distance, 74 million miles is more than half the distance from the Earth all the way to the Sun. If the edge of J1407b's rings were placed where our Sun is, the outer rings would reach past the orbit of Mercury and almost touch Venus. This colossal structure is made up of over 30 individual rings, packed with trillions of tons of cosmic dust, rock, and pulverized ice. The sheer gravitational pull required to hold this massive disk of debris in place is immense. As this giant spins through space, its rings act as a violent, churning cosmic highway. But there's an even more fascinating detail hidden within this giant crown. When astronomers looked closely at the light patterns, they noticed massive, clean gaps inside the rings, just like the lanes on a highway. These aren't empty spaces by accident. These gaps are being carved out by completely new exomoons that are currently being born inside the rings. One specific gap is so wide that scientists believe a moon roughly the size of Mars, or even Earth, is orbiting inside it, acting like a cosmic vacuum cleaner, sweeping up all the dust and rock in its path. J1407b isn't just a planet. It is a giant, living planetary laboratory, a nursery where worlds are being forged out of a crown of dust. Human beings have an innate, deeply embedded obsession with legacy, size, and leaving a mark on the world. We build towering skyscrapers like the Burj Khalifa, we carve monuments into the faces of mountains, and we build massive digital empires, all driven by a subconscious desire to say, "Look at me, look at what I created, look at how big my footprint is." We walk around our planet thinking we are the masters of architecture and design. But J1407b steps out of the cosmic dark to completely shatter our collective ego. It shows us that gravity, a completely silent, unfeeling, invisible force of nature, can create an architectural masterpiece that puts all of human history to shame without even trying. Imagine living on a planet orbiting inside that ring system. Your sky would never be empty. Every morning, you would wake up to massive, glowing arches of silver and gold dust stretching from one horizon to the other. Your nights would be lit up not by a single, lonely moon, but by the reflective glow of trillions of ancient rocks spinning in a beautiful, synchronized ballet. Looking at J1407b forces us to confront our own insignificance, but in a way that is deeply comforting. It reminds us that our human dramas, our political battles, and our daily stresses are entirely microscopic. We live on a tiny, clean rock with no rings, tucked away in a quiet corner of the galaxy. J1407b is a reminder that the universe is a grand canvas of art, and we are incredibly lucky to be the conscious observers who get to look out into the dark and appreciate the scale of the masterpiece. From the time we are tiny children, humans are instinctively, universally afraid of the dark. We turn on night lights in our bedrooms. We avoid walking down unlit alleys, and our minds fill the shadows with imaginary monsters and predators. We fear the dark because it represents the total absence of information, a place where our eyes fail us and we are left completely vulnerable. Now, take that primal childhood fear and expand it to the size of a giant planet. Imagine traveling through space and coming across a world that is darker than coal, darker than black acrylic paint, and darker than any shadow you have ever seen on Earth. A planet so terrifyingly void of light that it absorbs 99% of all the starlight that hits it, making it look like a literal physical hole ripped directly out of the fabric of the universe. If you were to sail past it in a spaceship with your headlights off, you wouldn't see a planet at all. You would just see the stars behind it suddenly vanish into an infinite, suffocating abyss. But as you get closer, you realize the abyss isn't entirely dead. Through the pitch-black darkness, a faint, eerie, demonic red glow begins to bleed through the atmosphere, like the dying embers of a campfire burning in the middle of a graveyard. Welcome to Trace 2b, the absolute dark night of the cosmos. Discovered in 2006 by the Transatlantic Exoplanet Survey using a tiny 4-inch telescope, and later confirmed by NASA's Kepler Space Telescope, Trace 2b is a gas giant located about 750 light-years away from us in the constellation of Draco. It is roughly the same size and mass as our Jupiter, but that is where all similarities completely end. Our Jupiter is a vibrant, colorful world. It is wrapped in brilliant, swirling bands of orange, white, and red clouds made of ammonia and water ice, which reflect more than a third of the sunlight that hits it. Jupiter wants to be seen. Trace 2b, however, actively devours light. When scientists measured the reflectivity, or albedo, of Trace 2b, they were absolutely stunned. The planet reflects less than 1% of the light from its parent star. To put that into perspective, it is less reflective than solid coal, black asphalt, or matte paint. It is the darkest planetary body ever discovered in the history of astronomy. So, what makes this world so terrifyingly dark? The answer lies in its extreme atmosphere and chemistry. Trace 2b orbits its host star at a distance of just 3 million miles, which is incredibly close compared to Earth's 93 million miles. Because of this tight grip, the planet is blasted by intense stellar radiation, heating its atmosphere to a blistering 1,800 degrees Fahrenheit. At this extreme temperature, the planet cannot form peaceful, reflective clouds of ammonia or ice like Jupiter does. Instead, its atmosphere is a volatile, churning cauldron of vaporized sodium, potassium, and titanium oxide gas. These specific chemicals are absolute gluttons for light. When photons of light travel from the star and hit Trace 2b, these vaporized metals don't bounce them back into space. They absorb them, trapping the energy inside the chemical bonds of the atmosphere. The planet is quite literally eating the light of its own sun. But the story gets even more cinematic. Because the planet is hosting a temperature of 1,800 degrees Fahrenheit, it is a massive thermal engine. It is so hot that it emits its own thermal radiation. If you were to look at Trace 2b with human eyes, you wouldn't just see a black circle. The intense internal heat causes the gas to glow with a dull, menacing, infrared red color. It looks like a giant ball of burning charcoal drifting through the void. It is a world of pure, unadulterated darkness, wrapped in veins of silent, bleeding fire. Trace 2b hits us directly in our emotional and philosophical core because it represents the ultimate manifestation of the unknown. As human beings, we associate light with life, truth, goodness, and hope. We say we are enlightened when we learn something new, and we describe our happiest moments as bright. Light is our ultimate safety blanket. Trace 2b takes that safety blanket and completely dissolves it. It forces us to confront the fact that light is actually a minority in the universe. We live on a planet bathed in golden sunlight, with blue skies and white clouds, but that is an anomaly. The natural, dominant state of the cosmos is, and always has been, the deep, silent dark. Yet, if you look past the initial terror of Trace 2b, there is a strange, profound, and melancholy beauty to it. It is a planet that refuses to show itself to the world. It keeps its secrets locked deep within its pitch-black atmosphere. It reminds us of those phases in our human lives when we feel completely consumed by darkness, whether through grief, depression, or loneliness. Times when we feel like we are absorbing all the pain around us and reflecting nothing but shadows to the outside world. But just like Trace 2b, even in our darkest, most shadowed moments, we are never completely dead or empty. Deep inside, beneath the surface of our struggles, there is still a warmth, a heat, a glowing ember of survival that refuses to be extinguished. Trace 2b is a cosmic mirror showing us that darkness isn't just the absence of light. It can be a physical, heavy, powerful presence that carries its own hidden, burning fire. From the moment we enter our very first science classroom as children, we are taught that the world operates on strict, unyielding rules. We learn that fire burns, heat melts, and cold freezes. We know with absolute certainty that if you toss an ice cube onto a roaring hot stove, it will instantly sizzle, melt into water, and vaporize into steam. This is the baseline logic of our reality. It is a fundamental law of physics that we rely on every single day. But now, I want you to discard everything you think you know about chemistry. Imagine traveling 33 light-years away from Earth to a world that looks like a massive, shimmering ball of solid ice. It looks frozen, static, and peaceful. But as your spaceship sensors scan the surface, your jaw drops. The temperature on this solid ice sheet isn't below zero. It is a roasting, blistering 800 degrees Fahrenheit, hot enough to easily melt lead, hot enough to turn human bones to ash in seconds. Yet, the ice does not melt. It does not steam. It sits there, a massive global glacier, burning fiercely in the vacuum of space. Welcome to Gliese 436b, the planetary paradox where nature defies its own logic and forces fire and ice to live in a permanent, impossible marriage. Discovered in 2004 by astronomers using the radial velocity method, Gliese 436b is located relatively close to our solar system in the constellation of Leo. In terms of physical scale, it is often categorized as a hot Neptune. It possesses roughly the same physical dimensions and mass as our solar system's Neptune, about 4 times the size of Earth. But while our Neptune is an ice giant tucked away in the deep, freezing, dark outer edges of our solar system, Gliese 436b has pulled off a terrifyingly dangerous cosmic maneuver. It lives practically on top of its parent star. Gliese 436b orbits a faint red dwarf star at a distance of just 2.5 million miles. To put that in perspective, Earth sits 93 million miles away from the Sun. This exoplanet is so unimaginably close to its stellar host that it completes a full trip around the star, an entire planetary year, in just 2 days and 15 hours. Because it is practically skimming the surface of this star, it is constantly subjected to a relentless, punishing bombardment of stellar radiation. This radiation cooks the planet's outer layers, driving surface temperatures up to an incredible 800 degrees Fahrenheit, about 430 degrees Celsius. Under normal cosmic conditions, a world exposed to this kind of heat would be a barren, molten rock or a puffy, boiling gas giant. So how can a planet wrapped in a thick coat of water ice exist in this hellish environment? The secret lies in a cosmic tug-of-war between extreme heat and monstrous, crushing gravity. Gliese 436b is incredibly dense. The sheer mass packed into this world creates an immense, overwhelming gravitational field. When you look at the planet's water layer, the outer heat is desperately trying to boil the water molecules, pushing them to expand, vaporize, and fly off into space as steam. But the planet's gravity acts like an invisible, heavy hand, pushing back down with unimaginable force. It squeezes the water molecules together so tightly that they are physically forbidden from expanding into a gas. In physics, when you subject water to pressure that is millions of times greater than the atmospheric pressure of Earth, you create exotic states of matter that do not exist naturally on our planet's surface. The water on Gliese 436b is compressed into a structural form known to scientists as Ice-X, Ice-10. Unlike the ice in your kitchen freezer, which is light, buoyant, and melts the moment it touches room temperature, Ice-X is a hyperdense, crystalline structure. It is harder than steel, heavier than rock, and its molecular bonds are so tightly locked in place by gravity that even an 800-degree furnace cannot break them apart. The planet is wrapped in a permanent, solid crust of burning ice. To make things even more cinematic, the intense heat causes the outer gaseous layer of hydrogen to slowly bleed into space, leaving a massive, glowing tail of vapor trailing behind the planet for millions of miles, making it look like a giant, burning hybrid of a planet and a comet. Gliese 436b is a profound slap in the face to human binary thinking. As human beings, we love to categorize our emotions, our relationships, and our lives into neat, opposing boxes. We believe that things are either black or white, good or bad, hot or cold. We assume that two conflicting forces cannot occupy the same space at the same time. We tell ourselves that you cannot be furious with someone you love, or that you cannot feel deep joy while simultaneously experiencing profound grief. But Gliese 436b steps out of the cosmic twilight zone to show us that the universe absolutely loves contradictions. It proves that something can burn with the fury of a furnace while remaining completely, totally frozen at its core. If we look closely, this bizarre planet is a perfect, poetic mirror for the human heart. Think about the times in your life when you have gone through an immense emotional trauma. The loss of a dream, a bitter heartbreak, or a deep betrayal. On the outside, your life might look like a blazing furnace of activity, anger, or survival. You are moving forward, working, screaming, and burning with intensity. But deep down, beneath the surface of your daily armor, your emotions have been compressed by the heavy, crushing weight of reality into a solid, unyielding glacier. You are frozen on the inside, yet you are burning on the outside. Gliese 436b teaches us that survival doesn't always look clean or logical. Sometimes, to survive the harshest environments life throws at us, we have to hold opposing forces within ourselves. It tells us that it is entirely okay to be a beautiful, chaotic paradox, frozen in our boundaries, yet burning with our passions. There is a unique, profound sorrow that comes with knowing the exact date of an impending tragedy. As humans, we find comfort in the unpredictability of the future. We live our lives under the beautiful illusion that tomorrow is always guaranteed. We build plans for next year, next decade, and retirement, deliberately shielding our minds from the reality of our own expiration dates. Now, I want you to look out into the cosmos and find a world that has no such luxury. Imagine a giant, majestic planet floating in the dark that knows exactly how much time it has left to live. It is a world undergoing a slow, agonizing public execution, and its killer is its own mother star, the very sun that gave it life. Every single second of every single day, this star is reaching out with invisible gravitational claws, violently ripping the planet apart, stretching it out of shape, and drinking its atmosphere like liquid gold. It is a world that has been twisted from a beautiful sphere into the tragic shape of a deformed, bleeding egg. Welcome to WASP-12b, the ultimate cosmic tragedy of a world running out of time. Discovered in 2008 by the Wide-Angle Search for Planets, WASP Consortium, WASP-12b is a gas giant located roughly 1,200 light-years away from us in the constellation of Auriga. On paper, it is a hot Jupiter, possessing a mass about 1.4 times greater than our solar system's largest planet. But while our Jupiter sits at a safe, respectful distance of 484 million miles from our Sun, enjoying a stable, peaceful existence, WASP-12b made the fatal mistake of forming too close to its parent star. WASP-12b orbits its star at a terrifying distance of just 1.3 million miles. It is so unbelievably close that the gravitational forces at play are completely cataclysmic. The planet flies through space at a frantic speed, completing an entire orbit, a full planetary year, in an astonishing 24 hours. Think about that. While you take a single day to sleep, go to work, and come home, WASP-12b has completed an entire journey around its Sun. Because of this extreme proximity, the planet is trapped in a phenomenon known to astrophysicists as Roche-Lobe overflow. The gravitational tidal forces exerted by the star on WASP-12b are so intense that they completely overpower the planet's own internal gravity. The star is pulling on the front side of the planet with vastly more force than the backside. This violent, cosmic game of tug-of-war has physically distorted the planet. WASP-12b is no longer a smooth, round ball. It has been stretched, warped, and elongated into the distinct shape of a massive cosmic egg. But the physical deformation is only the beginning of the horror. The star's intense heat has raised the planet's surface temperature to a searing 4,000 degrees Fahrenheit. This extreme thermal energy has caused WASP-12b's atmosphere to puff up, swell, and expand past its safety limits. The star's gravity is actively stripping this expanded atmosphere away, tearing off massive sheets of hydrogen and helium gas. Every single second, the star devours roughly 6 billion tons of WASP-12b's planetary mass. The gas is pulled into a glowing, swirling whirlpool of matter that spirals directly into the mouth of the star, creating a massive, glowing bridge of fire between the parent star and its dying child. Astronomers tracking this planet with the Hubble Space Telescope have delivered a definitive verdict. WASP-12b is on a cosmic death march. It is spiraling closer and closer to its star with each passing year. It has less than 10 million years left before it is completely torn apart and swallowed whole. In cosmic terms, 10 million years is a mere blink of an eye. WASP-12b is a ghost world, a planet that is actively being digested by the universe. The tragedy of WASP-12b strikes a deeply sensitive chord within the human psyche because it speaks directly to our fears of vulnerability, codependency, and mortality. In our human lives, we often find ourselves in situations or relationships that are inherently toxic, yet we cannot seem to break away from them. We find ourselves bound to jobs, habits, or people that slowly drain our energy, strip away our identity, and distort who we are, simply because we are locked into their powerful orbit. We bleed our essence into things that do not love us back, feeling our shapes change as we try to please a force that is slowly consuming us. WASP-12b is the ultimate cosmic illustration of this struggle. It cannot escape the gravity of its star. It is trapped in a fatal embrace with the very entity that gives it light and warmth. It flies through the void, changing its shape, losing billions of tons of its true self every single second, just to stay in the dance. But there is also an incredibly beautiful, existential lesson hidden within this dying world. WASP-12b reminds us to look at the time we have with a sense of urgency. When we realize that even massive planets, thousands of times larger than our entire civilization, have an expiration date and can be wiped out of existence, it makes our tiny, fleeting human lives feel incredibly precious. WASP-12b is a reminder that nothing lasts forever. It asks us to look at our own orbits, to evaluate what is consuming us, and to appreciate the beautiful, stable balance of our own Earth. We live on a world that isn't being torn apart, a world that has billions of years left to breathe. WASP-12b tells us to cherish the shape we have today, because out in the deep dark, time is always running out. We have all experienced the intense, moody atmosphere of a heavy summer rainstorm. You step outside, feel the sudden drop in temperature, pull up your collar, and open an umbrella as heavy, cool water droplets splash against the pavement. Water rain is a symbol of life, a natural reset button that cleanses our cities and feeds our forests. But now, I want you to erase that peaceful image from your mind. Imagine stepping onto a world where you cannot look up at the sky because doing so would instantly melt your eyes out of their sockets. Imagine an atmosphere where the clouds hovering above you aren't made of soft water vapor, but of concentrated, vaporized heavy metal. On this planet, when the sky darkens and a storm rolls in, the droplets hitting the ground aren't cold, liquid water. They are blazing, brilliant, blinding drops of pure, boiling, molten iron. It is a relentless, metallic deluge that strips away layers of rock and covers the entire landscape in a burning, liquid metal ocean. Welcome to WASP-76b, a hellscape where the fundamental elements of industrial civilization fall from the heavens like tears of fire. Discovered in 2016 by the Wide-Angle Search for Planets Consortium and later analyzed using the planet-hunting espresso instrument on the Very Large Telescope in Chile, WASP-76b is a masterclass in cosmic extremity. Located roughly 640 light-years away from Earth in the watery constellation of Pisces, this world is a colossally bloated gas giant, nearly twice the physical width of our Jupiter, yet slightly lighter in mass. Its immense volume is a direct consequence of the absolute violence inflicted upon it by its parent star. WASP-76b is locked in a suicidal cosmic orbit. It sits so close to its massive, burning sun that it completes a full loop around it in just 1.8 Earth days. Because of this extreme, suffocating proximity, the planet has become tidally locked by gravity. One side of WASP-76b is permanently turned toward the star, trapped in a never-ending, blinding day, while the other side faces the frozen, black void of interstellar space in a state of eternal night. Let's look closely at the terrifying atmospheric mechanics of this split existence. The day side of WASP-76b is subjected to a relentless nuclear-grade blast of stellar radiation. Temperatures here soar to a staggering 4,400 degrees Fahrenheit, about 2,400 degrees Celsius. This is not just hot enough to melt rock. It is hot enough to literally break down molecules into individual atoms and vaporize heavy metals. On this permanent day side, iron doesn't exist as a solid metal or even as a glowing liquid pool. The heat is so monstrous that iron evaporates. It turns into a transparent, ultra-hot gas that rises high into the planetary atmosphere, forming massive, invisible clouds of vaporized metal. Meanwhile, on the night side of the planet, things are drastically different. Because it never receives a single ray of sunlight, the temperature drops significantly, hovering around a still roasting but comparatively cooler 2,700 degrees Fahrenheit, about 1,500 degrees Celsius. This massive 1,700-degree temperature difference between the two hemispheres unleashes global atmospheric chaos. Ferocious, supersonic winds, driven by the planet's extreme thermal rotation, howl across the border from the day side to the night side, carrying the invisible clouds of vaporized iron along with them. The moment that vaporized iron crosses the atmospheric boundary into the cooler night side, the laws of thermodynamics take over. the temperature drops below the boiling point of iron. The iron gas panics, rapidly condenses, and transitions back into a liquid state. Suddenly, the night sky is filled with heavy, dark, glowing red clouds of liquid metal. The winds die down just enough for gravity to do its job. Trillions of tons of liquid, molten iron begin to precipitate from the sky, screaming down through the atmosphere in a heavy, continuous, metallic downpour. If you could survive the atmospheric pressure and stand on the night side of WASP-76b, you would witness a scene of pure, industrialized horror. A pitch-black world lit up only by the terrifying, glowing red streaks of liquid metal rain splashing into churning, boiling lakes of molten iron below. WASP-76b hits us directly in our philosophical core because it takes iron, the very material that defines human strength and progress, and turns it into something completely fragile and transient. Throughout human history, iron has been our ultimate symbol of permanence. We talk about an iron will, an iron curtain, or an ironclad contract to describe things that cannot be broken, bent, or compromised. We used iron to forge the tools that built the modern world, the railroads that connected empires, the swords that decided the fates of nations, and the steel skeletons of our tallest skyscrapers. Iron is our anchor. It represents our mastery over nature. But WASP-76b stands out there in the depths of space as a humbling reminder of our own cosmic limitations. It shows us that the materials we rely on to build our unyielding fortresses and empires are, to the rest of the universe, nothing more than a passing weather pattern. What we consider solid, heavy, and permanent can be melted down, vaporized, and blown away like dust if the universe decides to turn up the temperature just a little bit. It forces us to confront the inherent fragility of our creations. Our grandest steel structures, our massive machines, and our symbols of military and industrial power are entirely dependent on the specific gentle temperature and pressure of Earth. WASP-76b tells us that true, enduring strength cannot be found in physical materials, metals, or structures. Material things can be turned into rain. True strength lies in the invisible, adaptable power of the conscious mind. The only thing in the universe capable of looking at a sky raining liquid iron and understanding the beautiful, terrifying physics behind the storm. In 1977, the world was introduced to one of the most iconic, visually poetic scenes in cinema history. A young, restless farm boy named Luke Skywalker walks out into the vast, lonely desert of the planet Tatooine. Disappointed, trapped, and longing for a grander purpose in life, he stops at the edge of a sand dune. As the sweeping, emotional orchestral score of John Williams begins to play, Luke looks out at the horizon and watches not one, but two distinct suns. One a brilliant white gold, the other a deep, warm orange, slowly sink beneath the desert horizon together. For decades, that double sunset was considered the ultimate symbol of science fiction fantasy, a beautiful dream conjured up by human imagination. But the universe doesn't care about our boundaries between fiction and reality. In 2011, NASA's Kepler Space Telescope looked deep into the constellation of Cygnus and found something that changed astronomy forever. A real, physical planet orbiting two stars at the exact same time. A world where science fiction officially became science fact. If you were to stand on its surface, you would cast two separate shadows, and at the end of every day, you would watch a real-life binary sunset paint the sky in colors we have never even seen on Earth. Welcome to Kepler 16b, the real-world Tatooine that proves the universe is a romantic artist at heart. Located approximately 200 light-years away from our solar system, Kepler 16b is what astrophysicists officially classify as a circumbinary planet. Before its discovery, many scientists believed that such a world could not exist. The gravitational mathematics of a binary star system are incredibly chaotic, with two massive stars constantly pulling on each other and spinning around a shared center of mass. Any planet trying to orbit them should theoretically be torn apart by conflicting gravitational tides, or thrown violently out into the cold wilderness of interstellar space. But Kepler-16b managed to find the perfect, golden mathematical pocket of stability. It orbits a binary star system composed of two celestial parents. Kepler-16a, a warm, orange K-dwarf star about 69% the mass of our Sun, and Kepler-16b, a smaller, cooler red dwarf star only 20% of our Sun's mass. These two stars dance around each other tightly, completing a full orbital rotation every 41 days. Kepler-16b sits comfortably outside this inner dance, orbiting both of them at a distance of about 65 million miles, roughly similar to the orbit of Venus in our own solar system. It takes the planet 229 Earth days to complete a full circuit around its twin suns. Because it is orbiting two moving targets, the daily experience on Kepler-16b is a constantly shifting, dynamic symphony of light. The two suns are continuously changing their positions relative to each other from the planet's perspective. Sometimes, the smaller red star passes directly in front of the larger orange star, creating a stunning stellar eclipse. Other times, they sit on opposite sides of the sky, illuminating the landscape from two completely different angles. If you stood on this world, your shadow would be a double image. One shadow would be sharp and dark, cast by the brighter orange star, while the second shadow, overlapping the first at a strange angle, would be softer and tinged with a faint, reddish hue from the red dwarf. However, despite its romantic visual description, Kepler-16b is not the hot, sandy desert of Tatooine. It is a cold, inhospitable giant made mostly of gas, ice, and rock, possessing a mass roughly similar to Saturn. Its surface temperatures hover around a freezing -100 degrees Fahrenheit to -150 degrees Fahrenheit, -73 degrees Celsius to -101 degrees Celsius. The atmosphere is a thick, frigid envelope of hydrogen, helium, and methane. Yet, scientists believe that beneath this gaseous shroud, the planet may possess a solid, rocky core. If future humans could construct a floating outpost within the upper cloud decks of Kepler-16b, they would look out at a sky of frozen methane clouds, illuminated by the synchronized, dual rays of a twin solar system. Why does the image of a double sunset move us so deeply? Why did a fictional scene from a 1970s movie resonate across generations? And why did the scientific discovery of Kepler-16b send waves of awe through the human collective consciousness? It is because human beings are fundamentally terrified of isolation. We are a social, communal species, and we spend our entire lives searching for a counterpart, a partner, a soulmate, someone to share the heavy burden of existence with. We look at our own lonely, solitary sun, sitting isolated in the center of our solar system, and we subconsciously project our own feelings of loneliness onto it. Kepler-16b offers us a beautiful, poetic alternative to that cosmic isolation. It shows us a system where partnership is the fundamental law of gravity. It is a world raised by two parents, held in place by a shared, balanced embrace of two different stars. It proves that even out in the cold, unfeeling void of space, harmony, connection, and balance are possible. When we watch a single sunset on Earth, we often feel a sense of melancholy, a reminder that another day has slipped away into the past, leaving us a little older and closer to the dark. But a double sunset on Kepler-16b feels like a conversation. It is a visual representation of dualism, light and shadow, heat and cold, two forces working together to create a stable reality. Kepler-16b teaches us that you don't have to face the darkness alone. It tells us that even when the environment around you is freezing, harsh, and filled with gas storms, you can still find stability and beauty if you are anchored by the right connections. It stands as a shining, multicolored monument in the dark, reminding humanity that the universe isn't just a place of destructive black holes and lonely voids. It is also a place that accommodates the beautiful poetry of togetherness. Imagine walking into the most exclusive, heavily guarded jewelry vault on Earth. Beneath the bright security lights sit rows of deep red rubies and shimmering blue sapphires. To own just one of these stones, a human must spend thousands of dollars. To own a handful is a mark of extreme royalty. We lock them away in steel safes. We wear them on our bodies to project power, and we treat them as timeless treasures that define material wealth. Now, look up into the night sky, past the familiar stars, and fix your gaze on a world where these very same precious gemstones aren't locked in a vault. They aren't even buried in the dirt. Imagine a world where rubies and sapphires are completely worthless because they are as common as the air you breathe. Imagine standing on a planet where a sudden wind blows, and as you look up, you see massive, glittering clouds of liquid precious gems swirling across the horizon, catching the light of a blazing star and turning the entire sky into a moving, blinding kaleidoscope of pure, unadulterated luxury. Welcome to HAT P7b, a gas giant wrapped in a permanent cloak of liquid jewels. Discovered in 2008 by the HATNet project and later studied in extreme detail by NASA's Kepler Space Telescope, HAT P7b, also known as Kepler 2b, is a massive exoplanet located roughly 1,040 light-years away from Earth in the constellation of Cygnus. It is a true heavyweight of the cosmos, a gas giant that is about 40% larger than our Jupiter and significantly more massive. But what caught the attention of astrophysicists wasn't its immense size. It was the wild, erratic weather patterns reflecting from its upper atmosphere. HAT P7b is another victim of extreme stellar proximity. It orbits its host star, a star much larger and hotter than our Sun, at a distance so close that its entire orbital period is just 2.2 Earth days. Just like the other worlds trapped in this suicidal dance, HAT P7b is tidally locked. Its day side is frozen in a perpetual state of blinding solar bombardment, while its night side faces the pitch-black void of interstellar space. The temperatures on the day side of HAT P7b are absolutely catastrophic, soaring to an estimated 4,700 degrees Fahrenheit, around 2,600 degrees Celsius. This level of heat crosses a major chemical threshold. It doesn't just vaporize water or melt rock. It alters the structural properties of advanced minerals. Scientists analyzing the light curves of this planet discovered that its atmosphere is incredibly rich in a mineral called corundum. For those unfamiliar with geology, corundum is an aluminum oxide mineral. On Earth, corundum is incredibly rare and hard, second only to diamond. When corundum contains trace amounts of iron, titanium, or chromium, it forms the beautiful, sparkling gemstones we call sapphires and rubies. On the day side of HAT P7b, the 4,700-degree heat is so intense that this mineral cannot exist in its solid gemstone form. The corundum is completely vaporized, turning into a thick, invisible, metallic gas that saturates the atmosphere. However, because the planet has a freezing night side, a massive atmospheric pressure gap is created. Violent, catastrophic winds, moving faster than any hurricane ever conceived, drag this vaporized corundum across the atmospheric border into the cooler night side. The moment the metallic corundum gas hits the night side, the temperature drops just enough for the mineral to condense. It transitions from a gas back into a liquid. Suddenly, the sky of the night side is filled with massive, sweeping clouds of liquid ruby and sapphire condensate. As these jewel clouds travel back toward the day side via the planet's shifting jet streams, They catch the first rays of the blazing morning sun. The sky quite literally ignites in a blinding, sparkling display of deep blues and glowing reds as trillions of carats of liquid gemstones catch the light, before the crushing heat of the day side vaporizes them all over again. It is a never-ending cycle of gemstone weather, a planet that changes its jewelry with every passing hour. Hat-P7b strikes a deep, resonant chord within human philosophy because it takes our ultimate symbol of material greed and turns it into common, passing clouds. Since the dawn of civilization, humans have fought, bled, and died for shiny stones. We have enslaved populations to dig into dark, dangerous mines just to pull out a single red or blue crystal. We use these stones to validate our worth, to show that we are superior to others, and to symbolize things like eternal love and commitment. We have allowed our societies to be dictated by the illusion of scarcity. But Hat-P7b stands as a brilliant, mocking monument in the deep dark of space, laughing at our definitions of wealth. It shows us that out in the grand expanse of the universe, the very things we lock in vaults are nothing more than condensation. Nature doesn't care about carats, value, or fashion. To the universe, a ruby is just aluminum and oxygen under heat. A sapphire is just a chemical reaction to a changing wind. This glittering gas giant forces us to reevaluate what true beauty really is. If you could transport a human to the upper atmosphere of Hat-P7b, they wouldn't see a treasure chest. They would see a terrifying, turbulent storm that would instantly kill them. It teaches us that the real treasures of existence aren't the inanimate, crystallized rocks we wear on our fingers. The real treasure is the consciousness that allows us to perceive beauty in the first place. A planet made of liquid gems is magnificent, but it cannot appreciate itself. It spins in the dark, blind and unfeeling. We, on our humble planet of mud and water, have the unique privilege of looking out at the cosmos and finding wonder in its design. Hat-P7b tells us to stop looking for value in things that are rare on Earth and start finding value in the fact that we are alive to witness the grand, multicolored artistry of the universe. When we look at our grandparents, we see the history of our families written in the gentle lines of their faces. We sit at their feet and listen to stories of a time long before we were born, a world of different technologies, different struggles, and an entirely different way of life. They represent our anchor to the past, a living reminder that we are just the latest chapter in a very long story. Now, I want you to look past our solar system, past the youngest star clusters, and travel to the absolute edge of our galaxy. Inside a crowded, chaotic swarm of ancient stars, there lives a planet that scientists call Methuselah. Our Earth is roughly 4.5 billion years old, a relative toddler in space. But this planet is an astonishing 12.7 billion years old. This world was already ancient, spinning quietly in the dark billions of years before our sun even ignited, long before Earth even existed as a cloud of dust, and just a mere 1 billion years after the Big Bang itself. It is the ultimate grandmother of the cosmos, a silent, weathered survivor that has watched the entire history of the universe unfold from the front row. Discovered in 1993 using pulsar timing data and later confirmed by the Hubble Space Telescope in 2003, PSR B1620-26b is a gas giant located roughly 12,400 light-years away in the globular cluster Messier 4. It has a mass about 2.5 times greater than our Jupiter. But its mass is the least interesting thing about it. Its true wonder lies in its age and the bizarre, chaotic family dynamic it has survived over nearly 13 billion years of existence. To understand how miracle-like Methuselah's survival is, we have to look at its home environment. It lives inside a globular cluster, a dense, tightly packed ball of hundreds of thousands of ancient stars that formed when the universe was in its absolute infancy. Because the universe was so young when Methuselah formed, the cosmic chemistry was completely different. Heavy elements like iron, silicon, and carbon hadn't been forged in large quantities by dying stars yet. Methuselah had to be built out of the raw, primordial hydrogen and helium that left the Big Bang. It is a first-generation world, a pioneer of planetary formation. But its survival story gets even more dramatic when you look at the stars it orbits today. Methuselah does not orbit a peaceful, gentle sun like ours. It spins at a dizzying speed, blasting out intense, deadly beams of radiation across space like a cosmic lighthouse. The white dwarf is the burnt-out shell of another dead star. Methuselah's history is a cosmic thriller. Scientists believe the planet originally formed around a normal, healthy star on the outer edges of the cluster. But as the cluster swirled and stars brushed past each other over billions of years, Methuselah's original solar system drifted into the dangerous core of the cluster. There, it encountered a neutron star. In a violent gravitational tango, the neutron star stole the planet and its parent star, stripping the parent star down until it became a white dwarf, while the neutron star spun up to become a millisecond pulsar. Through all of this cosmic violence, through a stellar collision, a supernova explosion, the stripping of its parent star, and the chaotic gravitational tides of a crowded star cluster, Methuselah survived. It didn't get swallowed by the dying stars, and it didn't get thrown out into the freezing void. It held onto its orbit, continuing its silent, ancient journey through the dark, a monument of pure resilience. Methuselah hits us directly in our emotional core because it provides the ultimate sense of cosmic perspective. As human beings, we tend to view the world through the hyper-narrow lens of our own timelines. We get stressed about our daily routines, we fight over historical borders that have only existed for a few centuries, and we look at our lifetimes of 70 or 80 years as an eternity. We think our current epoch is the center of the universe's attention. But PSR B1620-26b steps out of the primordial mist to remind us of how beautifully insignificant our timelines truly are. This planet was spinning when the universe was dark, before the first heavy metals were born, before the Milky Way even fully took its modern spiral shape. It has sat in the dark, watching generations of stars ignite, burn bright, and collapse into dust. It has witnessed the entire biography of existence. When you look at Methuselah, your personal worries, your heartbreaks, and the political anxieties of our world suddenly lose their crushing weight. Our entire human history, every empire that rose and fell, every war fought, every love story written, and every breath taken by every human who ever lived, is just a microscopic fraction of a single second to this ancient world. It teaches us the beauty of endurance. It shows us that you can go through the most violent, disruptive changes. You can lose your original foundation, you can be thrown into chaotic environments, and you can watch everything around you collapse, and you can still find a way to maintain your orbit. Methuselah is a cosmic message of hope, telling us that survival is woven into the very fabric of creation, and that even the most fragile things can endure the test of time if they just keep moving forward. Human beings are obsessed with labels. From the moment we are born, society tries to place us into neat, predictable boxes. You are either a child or an adult. You are either a student or a teacher. You are either a success or a failure. We find comfort in these boundaries because they make the chaotic world feel ordered. We look up at the night sky and apply the exact same strict binary rules to the cosmos. A star is a giant, burning nuclear furnace that creates light, and a planet is a cold, dark rock or gas ball that orbits it. The line between them is absolute. But out in the deep wilderness of space, nature completely scorns our human categories. Imagine traveling to a world that suffers from the ultimate cosmic identity crisis. It is legally classified as a planet, but it burns with a fury that puts most stars to shame. It is a world so unimaginably hot that the very molecules that make up its atmosphere cannot hold themselves together. They are violently ripped apart into raw, chaotic atoms by a blistering 7,800 degrees Fahrenheit furnace. It is a planet that has abandoned its own planetary nature to live as a star, trailing a glowing, ghostly tail of vaporized heavy metals across the void. Welcome to KLT-9b, the rule-breaking hybrid that shatters the boundary between planet and star. Discovered in 2017 by astronomers using the Kilo-Degree Extremely Little Telescope, KELT, KLT-9b is located roughly 670 light-years away from us in the constellation of Cygnus. In terms of physical scale, it is an absolute giant, a gas giant nearly 3 times more massive than our Jupiter. But its mass is completely overshadowed by its environment. KLT-9b orbits a blue supergiant star called KLT-9, which is one of the hottest, most massive, and most violent stars known to astronomy, burning at a temperature of over 17,000 degrees Fahrenheit. Because KLT-9b orbits the stellar monster at a breakneck, terrifyingly close distance, it completes a full orbital revolution in just 36 Earth hours. This extreme proximity has locked the planet in a gravitational chokehold, rendering it tidally locked. The day side of KLT-9b is permanently exposed to the unmitigated, raw radiation of its blue supergiant parent. The result is a temperature configuration that completely shocked the scientific community. The day side of KELT-9b reaches a staggering 7,800 degrees Fahrenheit, about 4,300 degrees Celsius. To put this mind-boggling number into perspective, KLT-9b is hotter than the surface of most stars in our galaxy. It is hotter than almost every red dwarf star in existence, and it comes remarkably close to matching the surface temperature of our own sun, which burns at around 10,000 degrees Fahrenheit. If these calm explorations help you unwind, you might also subscribe, or leave a thought below. It helps other sleepy souls find their way here, too. For now, let your thoughts settle and let the night carry you the rest of the way. Sleep well and good night.